Alright, video 2. Here we go. So I've gotten a response from Tom on my initial post. So we'll go over these items in order here. Your x-axis has positive instead of negative feedback. So on this one, I did reverse the output gain per this line here, and initially that didn't work. I ended up screwing around with it for a while, and eventually I did get it to work. I seem to be having a bit of an issue getting the C program to upload properly. I've just been using the C program page, making the changes, and then hitting save, compile, download, run, but I've been having some issues with that. Also, after turning everything off and freshly booting everything up from scratch today, I had that x-axis try to run away on me again, even after these changes had been made. So that's a little bit of a concerning issue. I'm not sure what's going on there. Also, on the same topic, I couldn't necessarily understand why I would need to invert the output gain. I double checked all of my wiring on the X and Y axes, one of which was the one that was working fine and the other one is the one that was running away on me. I've double checked all my wiring, and I even went so far as to put a scope on the encoder output and look at the encoder signal on both of them, and they're identical. So I don't know why I would need to reverse one and not the other, but at any rate, that's more or less working now. So moving on. On the step response screen, use the move not step button. I have switched to using the move button. Believe that this is in response to the limit switch issue, because since I've switched to using the move button instead of the step button, my limit switches are working, which allowed me to put belts on the machine and actually start testing and tuning properly. And then this last line, follow the tuning methods in the wiki. A bit vague, but I'm working on it. I've read this wiki probably 6 times now. I still don't understand most of it, but I've been hammering on this section here. I have managed to get all 3 of the axes working, and if I move over there, let's see here, step response. We'll get to that one later. I believe that the objective here is, in simple terms, to try and get the red position line to follow the blue command line as faithfully as possible, and at as high a speed as possible. So that's the colored line video game I've been playing here. I've got channel 0 here. Looking pretty good. Channel 1. Also looking pretty good. And then the final here. This one was the most challenging, but it has all the weight on it, so I'm not entirely sure what is or isn't a valid number. I was getting better results reaching the top of the commanded position, just continuously increasing this p-value. I didn't see anything anywhere with a value anywhere near that high, but that's where I ended up. So D-gain. So while I was reading through the D-gain stuff, this line here. Although derivative gain is often used successfully in a control system, consider using lead lag filter, which performs in a similar manner but doesn't have the undesirable feature of increasing gain at high frequencies. I see all of the examples have a 0 in the D columns, so I did the same. I just left it at 0. Max level P and D, add I gain to improve accuracy, and remove steady state errors. I have gone ahead and used that little bit of I. I do think it made a small improvement. And then the final line here, feed forward to reduce errors. I wasn't really sure after reading this multiple times where I would start with this, so my initial guess was just to copy these settings. I have played around with it a little bit, and I saw this line here. The normal procedure to optimize feed forward is to select plot type, position error, and measure moves using the move command. So doing so, if I come over here to my step response screen, position error. So I initially started with those very, very low values and slowly just started increasing them until when I got to 1/10 in each of these columns, the axis just immediately locked up. I really didn't appreciate that. On this screen here, it's graphing output and position error, but I don't really know what my objective here on this particular screen is. I would just intuitively guess I'm trying to get rid of position error. So I think the goal is to try and make this blue line go straight across at 0. I've increased this about as much as I can before it locks up on me, and these values are dramatically higher than the example, and I still have all these erratic motions here, so I don't know where to go on that one. And then the final item that I saw on the tuning page is the filters. As far as I can surmise on the filters, the way that this works is using the bode plot screen. I would go to each of my channels, take a measurement, and then using this information, I can pick out certain frequencies and use those numbers to plug into the IR filter screen. So somehow these lines or these values down here represent numbers that would go in these fields, and then I assume I hit compute and send this over to the clipboard, and that should implement some kind of filtering that's gonna correct something that I see on this screen. My channel 1 has a lot of erratic readings in this phase category. channel 0 and channel 2 both look like they're more or less just straight lines across. I don't know what that actually means or what my objective is in terms of trying to course correct these lines. I think what would be most helpful is some example pictures. I do remember reading on this other system's website. They had a very simplified description of how to do the servo tuning, which has since apparently been replaced. But in that manual, they do have this section on each of these parameters where they give a bunch of example pictures, more or less breaking down what they did and why, with lots of graphical representations, so at least I can play the little video game and try to move the line the way that I'm supposed to. At any rate, that's where I'm at. Again, thank you so much for the help, and look forward to the next response from you.